Sorry for the interruption. I have been waiting here whole day, but they just skipped my talk when I was in the restroom, so sorry for the inconvenience. And before we start the actual talk, I have been working in LG AI research since they born, so it has been like 3 years since I worked in this AI industry, and also I also worked in Naver Global AI team. So that's my 4-year official career in this AI industry, and also personally I have been conducting research on AI since 2017. So I'm quite young, but I have around 8 to 10 years of machine learning research. Yeah, I take care. 제가 할게요. Good. So I'm right now assistant professor in graduate school of Metaverse, and I'm also research scientist, and I'm also machine learning engineer. And here are my list of contacts. So if you have any questions, please take a photo and contact me via LinkedIn or Twitter or X, or visit my website or send me an email. Okay. So our lab, multimodal interactive blah blah blah. Our lab's name is MIMIC, dedicated to advancing human interactive multimodal AI. And we are focusing on creating AI that can understand, communicate with, and empathize with humans. We are also interested in developing next-level AI systems capable of mimicking a wide range of human behavior. And before I came here, I have been working on Exaon Atelier, or Exaon Multimodal, which is the Korea's first multimodal large language model. And during my research, during 3 years of research, I have been spending hard time scaling GPU clusters. And there was, I spent whole night, 24 hours for a week and maybe months. And during it was 2021, I actually slept only 4 hours to solve problems with GPU clusters. And after those 3 to 4 years of research, I came here in Seogang, and I have been widening my research area to Metaverse, DePIN, and something called DeLoco. And I'm now also focusing toward decentralized AI training, how we should train AI, and how we build the framework. So, before we go into the main section, I will briefly introduce how I have been working in LG AI research. From 2021 to 2024, I have been developing LG AI research's first multimodal large language model, which was officially launched in 2024. And I had to do it all by myself because there was no teammate. So the LG's first multimodal large language model was 1.5B image to text multimodal model plus 7 billion parameters large language model. And it has been trained on 350 million images plus text corpus. And these are the screenshots from our live demo during the press conference in 2024 July. To train the 1.5 billion model, I have to first manage 350 million images. And it was high resolution images, which was dozens of terabytes. And during my time in LGI research, I was dedicated to object storage cluster based on S3 and Lustre on AWS. One of my main job was to shard the data, and pre-process the image to feed it to 512 GPUs without any overhead. And that's when I used FSX, one of the service in AWS, and using EC2 Ultra clusters to stream 350 million images without any overhead. Also, since it was really hard for me to manage all those EC2 Ultra clusters, I had to also use something called SageMaker. It was also launched in 2021. So I didn't want it to, but I was part of beta tester of SageMaker. And using this SageMaker, I was using 512 GPU SageMaker cluster, which made me to spend tens of thousands US dollars per day during the peak usage. And since it was controlled by something called SageMaker, 24% of budget was spent on networking overhead, not the actual GPU training. It was spent on networking overhead. And that's when I attempted to build on-premise alternative, but building an on-premise alternative required me to gather more teammates who should be ML ops expert, and that made me to drop the project. And that was what happened in late 2024, and that actually made me to come here and leave the company. So here are key lessons from EXA-1. Centralized scaling of GPU clusters is powerful, but also really expensive. And storage also, not the GPU itself, storage and network often dominate hidden costs. And that's when I found out that I need more democratized compute models. And that's why I'm here. I joined Graduate School of Metaverse in 2024 September. And my research focus is, of course, Metaverse, and of course, AI, and also DePIN. And the question I have right now is, can AI training leverage decentralized infra? Metaverse needs scalable AI. Virtual worlds require real-time generative models. And that's when DePIN comes. DePIN offers crowd-sourced infrastructure at global scale. And with synergy between metaverse, AI, and DePIN, it becomes decentralized compute for immersive AI. For those who doesn't know what DePIN is, DePIN stands for Decentralized Physical Infrastructure Network. Blockchains incentivize participants to provide services. For example, Azure provides GPUs, and Filecoin provides storage, and Helium provides wireless connections. And I'm quite new to this blockchain world. I have been looking at blockchain since last year September, but I wasn't that interested before. I found out there is some research called DeLoco from Google DeepMind. DeLoco stands for Distributed Low Communication Training. For normal GPU clusters, every update should happen in synchronized manner. But in this DeLoco algorithm, most of the updates are local updates. And after like 500 steps, the synchronization happens. And that allows us to more than 500 times less network traffic without accuracy loss. So as you can see from the figure from DeLoco, most of time replicas training for H inner steps, more than 500, are trained in local GPUs. For example, they try to train the network using TPU V4 located in United States and V100 server located in France, and TPU V5 in Japan, and A100 in England. And that's when local step happens. And after that, they do outer optimization. So this architecture allows decentralized cluster and also heterogeneous clustering. So this is how DeLoco works. Each node trains k steps locally and sends compressed gradients or parameters, but these gradients or parameters are only few megabytes, so this doesn't cause too much burden in network. And coordinator averages updates, which is originated from federated learning, and they call it variance of federated average. And after this internal step, outer optimizer updates the shared copy of parameters. And that's when DeLoco inspired us. My shallow background, knowledge on blockchain, and my previous attempts, I tried to train model using AWS, and this one paper, inspired me that we might be able to build AI training framework based on decentralized cluster. And the team, Google DeepMind team, trained the model using this algorithm, and they found out that it actually doesn't drop accuracy that much. But they only try to train LLM. So what I'm doing right now is to build general framework that trains large foundational models, including LLM or CLIP, which is vision language model, on DePIN cluster using the local principles. This will democratize access to massive AI training and also share compute rewards via blockchain tokens. So this is our team's basic concept of system architecture. This architecture needs coordinator service on-chain or off-chain, or multiple compute nodes, which can be GPUs or edge servers, something like TPUs or maybe some ASIC neural processing units. And, of course, incentive contract based on coins. And this distributed training workflow first distribute global model to nodes. And local training happens on private data. For example, if compute node A has a corpus on news data, their own news data, and compute node B has their own corpus of mathematics problems, and compute node C has their own chats, they can just train their local model. They can just train their local model based on their local training, based on their local private data. And if each compute node uploads model deltas, which is gradients or parameters, the federated aggregation coordinator aggregates and updates the global model. This is not new because there has been more than 5 years of research of this kind of concept, which we call federated learning. And also, if any compute nodes joins the network, joins the model training, token will be paid out proportionally to validated contribution. And there will be proof of uptime and proof of useful work. And there will be, of course, transparent accounting on blockchain. However, there are still open challenges. We should first secure aggregation with malicious nodes. And also, we also have to, so if we only use private data, there won't be any problem. But if we have to distribute data, if we also have to distribute data, we also have to consider efficient data distribution at petabyte scale. And of course, the main users will be AI developers, so it should be useful and easy to use for AI developers, not blockchain developers. So one of my goals is heading toward democratized foundational models. It will lower barrier to large-scale AI R&D, and it will also allow us to build community-owned model weights. And it will also share value creation, shared value creation through decentralized AI. Since the schedule was quite big stuff, I won't be able to answer the questions right now, but if you send me an email or send me a message through LinkedIn or X, I will be happy to answer to your all questions. Thank you.